All right, let's go ahead and go over this. For problem number 1, you have the square root of 50x over 4 square roots of 3x. Are we allowed to have radicals in the denominator? No. Now, when you're going to be working with that radical in the denominator by rationalizing, it might make it a lot simpler if you work with the 50 first. Remember, sometimes when you're working with really large numbers, you guys forget which factors or perfect squares are able to go into them. So I would strongly recommend for both of these problems that you actually simplify them first before you start working with that rationalization or with that multiplication of those monomials. That way you're working with smaller factors, okay, or smaller products, and you can factor them out a little bit easier. So the first thing that I would recommend doing is going ahead and breaking up the square root of 50x. What can we break it up into? 25 and 2x. Remember, the x is not perfect. That x still has to belong. Don't forget about that. So 25 for one of the square roots, and then square root of 2x for the other factor. Then down here at the bottom, we still have that 4 square root of 3x. Okay, we already know that 25 is a perfect square, so we can go ahead and factor or break that apart into 5, or simplify it to a 5. So we now have 5 square roots of 2x over 4 square roots of 3x. Now, to rationalize the denominator, what do I multiply both the numerator and denominator by? Just the 3x, the square root of 3x. It's the only thing that you're multiplying by. You don't have to multiply by the 4 because the 4 is fine. 4 is outside of the radical, so it's okay. You don't have to try to get rid of that. You only have to get rid of the radical. So you're going to multiply both the numerator and the denominator by the square root of 3x. Okay, now when I'm multiplying in the numerator, what am I actually multiplying together? Just the radicals. I'm only multiplying square root of 2x and square root of 3x together. The 5 is going to stay as it is. What's the square root of 2x times the square root of 3x? Square root of 6x squared. Square root of 6x squared. Okay? And then for my denominator, same thing. I'm going to be multiplying the square root of 3x times the square root of 3x. So I now get 4, which is outside, and then square root of 9x squared. Now, when I'm looking at this, is there any perfect square at the top? Is 6 perfect? Is x squared perfect? Yes. X squared is perfect, so we're going to be able to take the square root of that. 9's perfect? Yes. X squared is perfect? Yes. Okay, so this now is going to give us 5x square root of 6 over 4 times 3x, and there is no square root. What's 4 times 3x? 12x. So we now have 5x square root of 6 over 12x. Am I done? Why not, Jimmy? The x. I've got an x on the top and an x on the bottom, so what can I do with them? Cancel them out. They can cancel out. They are now gone. So your final answer for this problem should be 5 square roots of 6 over 12. That's your final answer. 5 square root of 6 over 12. Okay, let's take a look at problem number 2. Problem number 2, again, we have the square root of 40x cubed times the square root of 24x to the 5th. Let's go ahead and see if we can factor out the 40 and the 24 first. Variables I'm not going to worry about so much just because it's easy to go ahead and work with them at the very end. But the numbers, you're working with large factors. If I multiply 40 times 24, it's a lot larger than you'd want to work with. But you can actually go ahead and factor 40. What are the factors of 40 that are perfect? 4 and 10, right? We have square root of 4, and then the square root of 10, oops, and we'll leave the x to the 3rd power with it. What about 24? What can we break 24 up into? Say it louder. 4 and 6. So we'll do square root of 4 and square root of 6, and we'll do x to the 5th here. Okay, what are the square roots of 4? 2. So this is now going to give us 2 square root of 10 x to the 3rd times 2 square root of 6 x to the 5th. Okay, so we multiply the 2's and we multiply the radicals. So what's 2 times 2? 4. What's the square root of 10x to the 3rd times the square root of 6x to the 5th? 60x to the 8th. Good. Square root of 60x to the 8th. Okay, can 60 be broken down? Yes. What perfect square goes into 60? 4. So we have square root of 4. And what about x to the 8th? Is that a perfect square? Yeah, so I'm going to actually pair that with my 4. So square root of 4x to the 8th. And then the other factor for 60 is 15. Because 4 times 15 gives us 60. Okay, so here's our perfect square. What's the square root of 4? 2. So we now have 4 times 2. What's the square root of x to the 8th? X to the 4th. And then square root of 15. So then here's our final answer. 4 times 2x to the 4th is going to give you 8x to the 4th square root of 15. And then you are done. Any questions about these two warm-ups? They're just refreshers of what we've already done. Your homework is going to have problems like these on it, as well as the material that we're going to learn today, which is multiplying, not just with monomials. These are just monomials. But you're going to be multiplying a monomial with a binomial and a binomial with a binomial. Okay, so let's go ahead and turn to page 22. So more multiplication of the radicals. That's what we're focusing on. Monomials times binomials and binomials times binomials. But before we move on to that, let me focus on this part. This is still going to be a monomial times a monomial, technically, except I'm only going to be writing the monomial once and raising it to the second power. So if I have 2 square root of 5 raised to the second power, essentially this just means 2 square roots of 5 times 2 square roots of 5, right? But remember, when we have an exponent on the outside of parentheses, what operation or what property are we using? Distributive, right? We're distributing that exponent to each component on the inside. Now, as a refresher, let's see how many of you remembered. When I talked to you at the very beginning about square roots, I said square root of 5. A square root is technically an exponent. What kind of exponent is a square root? Who remembers? For house points, anybody? What do you think, Jimmy? It's not negative. What kind of exponent technically is a root? What was it? It's not a 2. Salmon? Not a 3. Because, I mean, if it was a 3, wouldn't I just write 5 to the second power? But it's 5 to what power, Ashton? Huh? Close, but not quite. When? Not 0, because 0 and a 0 exponent gives you what value, guys? A 1. Okay, so here's a refresher. I told you guys before. Musa? Huh? Nope. It's fraction. It's a root. A square root is a fraction of 1/2. Yes. When? Remember, any root is actually a fraction where the denominator is that root's base. Okay, so if it's a square root, the fraction is 1/2. If it's a cubed root, the fraction is 1/3. A fourth root, the fraction is 1/4. fourth. That's what a root really is. It's just an exponent in fraction form. So if I know the square root of 5 is 5 to the half power, then if I take the square root of 5 and I square it, that's essentially like saying I'm taking 5 to the half power and raising that to the second power, which means I'm really multiplying those two powers together. And if I multiply those two powers together, what do I get? What's a half times 2? 1. So this technically comes out to being 5 to the first power, or just 5. So the square root of 5 to the second power is just going to be 1. Or just 5. It's just the radicand by itself. Just a refresher of why a square root and a squared exponent are direct opposites of each other. It's like multiplication and division are inverse operations. Addition and subtraction are those inverse operations. A root and its similar exponent are inverse operations to each other. It's as if they don't exist and you're just left with whatever the radicand was. Okay? So the same thing is happening here, that you're taking that exponent of a 2 and you're applying it to the radical, or the square root, and you're applying it to the coefficient in front of the radical. So this now becomes 2 to the second power, and then the square root of 5 to the second power. What's 2 to the second power? 4. And what's the square root of 5 to the second power? 5. So it's essentially 4 times 5, which is 20. Okay, try a couple of these on your own, please. right, who wants to tell me what they got for problem number 2? 6 square root of 7 to the second power. Antonio? 252, very good. If you distribute that 2, so you're distributing it to the square root of 7, you're distributing it to the 6. So that becomes 6 to the second power, square root of 7 to the second power. 6 to the second power is 36. Square root of 7 to the second power is just 7. And then 36 times 7 is going to give you 252. Okay, what about for problem number 3? Jane? 125, very good. Again, distributing that 2 to the square root of 5 and to the 5. That gives you 5 squared, and then the square root of 5 squared. 5 squared is going to give you 25. Square root of 5 squared gives you 5, and then 25 times 5 is 125. Number 4, Ethan? 32. Again, distribute that 2 to the square root of 2 and to the 4. You then get 4 squared, square root of 2 squared. 4 squared is 16, square root of 2 squared is 2, and 16 times 2 gives you 32. Now for the fun one. Number 5. What do you think, Jimmy? Very good, 108x cubed. So again, you are distributing the exponent. You're distributing it to this first term right here, which is the square root of 3x. You're distributing it also to the x and to the 6. So there's 3 components that you're actually distributing that square to. So that now becomes 6 squared, x squared, square root of 3x squared. 6 squared is going to give you 36. X squared is going to give you x squared. And then the square root of 3x squared is going to give you 3x. So now you have to multiply 36 times 3, which is going to give you that 108. And then you have to multiply x to the second times x to the first, which gives you x cubed. So 108x cubed is your final answer. So then number 6, Brent, what did you get for number 6? 18x to the 7th. Very good. All right, so taking a look there, again, distribute that square to the square root, to the x to the 3rd, and to the 3. This now becomes 3 squared. This becomes x to the 6th power, because you're going to do that 3 times the 2, which is going to give you the 6. So x to the 6th power. And then the square root of 2x to the 2nd power. 3 squared is going to give you 9. Then you have x to the 6th. And then the square root of 2x to the 2nd power is just 2x. You would then multiply the 9 times the 2, which is going to give you 18. And then x to the 6th times x, which is going to give you x to the 7th. Any questions about those? Pretty basic. Okay, so now let's go ahead and get into where we're dealing with monomials multiplied by a binomial. So again, a monomial is a single term, like square root of 2. That is a monomial. A binomial is when you have a separation of terms. So you've got 2 terms that are separated by an addition or subtraction sign. So maybe 5 plus the square root of 12. So it's no different than what you've done before. What operation do you think you're going to be doing to multiply that square root of 2 by this binomial? What property? Distributive. You're just distributing your multiplication. You are taking that square root of 2 and you are distributing it to the 5 and you are distributing it to the square root of 12. So this gives you 5 times the square root of 2 plus it gives you the square root of 12 times the square root of 2. Well, 5 times the square root of 2 is just 5 square roots of 2. Square root of 12 times the square root of 2 is going to give you the square root of 24. Now we need to check to see, can we simplify or factor anything? Can 5 square roots of 2 be simplified? No. Square root of 2 is broken down as far as it can possibly go. What about square root of 24? Yes, you can go ahead and break that down. What are the factors that we can break square root of 24 by? 4 and 6. So we have square root of 4 and we have square root of 6. So we still have that 5 square root of 2 plus square root of 4 times square root of 6. Which one of those is the perfect square? The 4. Okay, so we now have 5 square roots of 2 plus 2 square roots of 6. Can we combine those? Why not? Because they're not like radicals, right? Square root of 2 and square root of 6 are not like radicals. Therefore, this is as finalized as we can possibly get it. That's our final answer. Try this one on your own. All right, you can tell me what they got. Richard? 3 minus Good. 3 minus the square root of 15. So again, you're just distributing. We're going to go ahead and multiply. Let me use the square root of 3 times the square root of 3, and then square root of 3 times the square root of 5. Square root of 3 times the square root of 3 is going to give you the square root of 9. Square root of 3 times the square root of 5 is going to give you the square root of 15. 9 happens to be a perfect square, so we can go ahead and simplify that to a 3. So we have 3 minus the square root of 15. 15 cannot be broken down any further, so there's your final answer. Okay, let's try a couple more. Go ahead and flip to page 23, please. Number 9? Somebody I haven't heard from yet? Emiliano? Very good. 4 square roots of 3 minus 3 square roots of 6. Okay, if we distribute, we're going to multiply square root of 6 times the square root of 8 and the square root of 6 times the 3 or the minus 3. Square root of 6 times the square root of 8 is going to give you the square root of 48. Square root of 6 times the 3 is going to give you 3 square roots of 6. 48 can then be broken down. You can break it apart into what? 16 and 3. So square root of 16, square root of 3, square root of 16 happens to be that perfect square. So you're going to have 4 square roots of 3 minus the 3 square root of 6. Okay? Problem 10. Demi? 7 square roots of 15. Very good. If we go ahead and multiply, we're going to get the square root of 27 times the square root of 5, and then the square root, 4 square roots of 3 times the square root of 5. Square root of 27 times the square root of 5 is going to give you the square root of 135. And then 4 square root of 3 times the square root of 5 is going to give you 4 square roots of 15. 135 can be broken down into the factors of 9 and 15. Square root of 9 happens to be perfect. That gives you 3 square root of 15. And then you still have this plus 4 square root of 15. So when you combine it all together, you're going to wind up getting 7 and then square root of 15. Because they are like terms, you can combine them. Okay? Number 11. Ashton? No, not quite. We'll go with Antonio. No, still simplify that last one. Jimmy? Yes, 3 square root of 2x minus 2x square root of 3. So again, if we do our distribution, that's going to give us 3 times the square root of 2x. You cannot do that together. You cannot multiply a 3 that's outside of a radical with the 2x that's inside the radical. The 3 has to stay on the outside. Then we're going to multiply the square root of 2x and the square root of 6x. So square root of 2x, square root of 6x becomes the square root of 12x to the second power. Okay, so you now have 3 square root of 2x minus square root of 12x squared. The 12 can be broken down to the square root of 4x to the second, because x to the second is a perfect square, and then the square root of 3. Okay, so you now wind up having 3 square root of 2x minus 2x square root of 3, and then you are done. So we're going to go ahead and stop here so that way you guys have time for working on your homework. We'll do the binomial times a binomial tomorrow. That means when you get onto the homework assignment, there are some questions that you're not going to be doing on the homework that I give you. So go ahead and turn it to page 24. Your homework assignment is going to go on page 24. Do not start it until I explain to you which problems you will not be doing yet. But you don't want to cross them off because you're going to do them later after we go over the FOIL process. Okay, so maybe just highlight them is what I would recommend doing. Highlight them so that you know not to do them right now. But it's going to go on page 24. In fact, I'll highlight them right now, and then you guys can catch up once I pass it out. So the problems that you will not be doing, and I'll leave this up here, you are not going to do problem 12 You are not going to do problem 15, 17, or 18. It's just those 4 problems that you will not be doing when I hand your homework out. Again, this is going to go on page 24 of your assignment. Everything else on here you can do.